some examples here. Oh yeah, so 24 you said is a confusing word problem. Let me start with that. So page 903, this is section 11.1, number 24. And I think the first thing I'm going to do is just kind of take a look at it with you, text-wise. Maybe we'll zoom in on it and read it a little bit. So, you have a long hill, and when we say that the grade is 7%, okay, grade equals 7%. Well, I just told you that the grade is really the slope. And how do you write 7% as a fraction? How do you write it as a decimal? What is it? Okay, so it's 0.07, but see, that's in the hundredths place. So the slope is really 7 over 100. Back when I took Algebra 1, or whatever it was, that was rise over run. And so when I say that the grade is 7%, what I'm saying is, for every 100 feet that I travel, I'm going to go uphill, well, 7 feet. That's the picture. So if you travel 100 feet, you're going to go uphill 7 feet. That's a grade of 7%. So it says you have a long straight stretch of mountain road. You see a tall tree standing perfectly plumb alongside the road. From a point 500 feet downhill from the tree, the angle of inclination from the road to the top of the tree is 6 degrees. Okay, so I have a perfectly straight tree. They tell me 500 feet downhill from the tree, the angle of inclination from the road to the top of the tree is 6 degrees. So the angle of inclination, remember, you start at the horizontal and you rotate upward. And so I'm picturing this angle here being 6 degrees. Okay? And we're 500 feet downhill. Ooh, I do have a question on this. Well, that's clearly the first step. We always follow a hint when they give you a hard problem, okay? They're telling me that this angle here is 94 degrees, and I'd really like to show that. Bless you. Show this. How can I do that? Well, I think I want to redraw my picture. I'll draw it a little bigger. So here's my tree over here. Make it a Christmas tree. Okay. And I'm going to draw the road in red. And the idea, again, is that I want to show that this angle here is 94 degrees. Let me call that alpha. That's the angle I don't know yet. I want to show that it's 94 degrees. Now I do know a few things, I guess. If I were to completely draw this right triangle down here at the bottom, that red triangle, I know a few things about it. I know it's a right triangle. Again, I know that the grade is 7%, so if it goes up 7 feet, it goes over 100 feet. Of course, that's not how many feet it goes over, right? It really goes 500 feet, and so it goes up how much? 35 feet, okay? And so maybe then that'll help me find alpha. And the way I'll do that is I'm going to call this angle here theta. And let's see if I can find theta. Because I know that theta plus alpha has to add up to what? (180°, right? And theta is in that red triangle there, which is a right triangle. So let me try that. Let me try that. So if I do this now, what I'll do is I'll say, which trig function do you think I want to use here? Do I want to use sine, cosine, or tangent, looking at the red triangle? It looks to me like I know opposite and adjacent, right? So I can say that the tangent of theta is 500 over 35. Okay? But again, I can see where this may be wrong. Let me give it a shot and see how the calculator does with that. So I know that the tangent of theta is equal to that. So if I want to find theta, what am I going to type in? Yep. So we'll try that. Again, I want to make sure this time I'm on degree mode, right? I think I usually am. Let me double check that. So if I press the mode button, yeah, I have degrees ready. And so I'm going to type in inverse tangent of 500, that's the opposite, over 35. See what angle theta is. So it says the angle theta is about 86 degrees, right? And so again, I could take 180 minus my answer, and I'm going to get about 94 degrees. Okay. So far, so good. I followed their hint. Theta is approximately 86 degrees, so alpha is 94. And so now I can draw that picture one more time. And see if I can compute the height of the tree. So again, at this point, I'm looking for this kind of situation. There's this long hill. I computed this angle here. Alpha is, oh, you're off the screen, thank you. So this alpha we figured out is 94 degrees, right? I need a better picture than that, guys. Let's try again. Tree. Long stretch of road. 94 degree angle, right? We want to know the height of the tree. We don't know it yet. I called this angle alpha, which means that across from alpha, I'll call this side A. Now, do we know anything else here? Yeah, Tyler? So we have the 6 degrees. Did we use that yet? Not really. So I know that, yeah, the 6 degrees is the angle of elevation, right? So from here to here, let me draw it in green, I know that this is 6 degrees. But I guess if I want to know the side over here, I'm going to call B. If I want to use the law of the sines, what I really need to know is from here to here, I'll call that beta. Because I know how the law of sines works, right? You need the side opposite the angle. Okay? And then maybe the other thing I need is I may need this angle over here, which I could call gamma. Right? So that might help also. I'm not there yet, that's for sure. The other thing we could do is I could determine, remember I just determined a couple things. I determined that this was 86 degrees. I determined that this was a right angle. And so it stands to reason that from here to here has to be 4 degrees, even though my picture is not to scale. Right? I really made the tree look a lot bigger than it does. Remember, this is 500 feet. The tree's not going to be 500 feet long, tall. So you get an extra 2 degrees. So beta here is 2 degrees. Beta is 2 degrees. How about gamma then? We could figure out it has to be what? 84, because we've used up 96 degrees of this triangle. So gamma now is 84 degrees. Okay? And do I know anything else? Well, I claimed that this was 500, and I claimed that this was 35. So it seems to me if we wanted to, we ought to be able to figure out this length of road here. In other words, if that's gamma, the book we've been calling the opposite side what? C. And actually, C's a real good name here, because how could you find C? Pythagorean theorem, right? So we're going to do, a squared plus b squared equals c squared. So I'll say that c is the square root of 500 squared plus 35 squared. And I'll get what c is. All right, let's give that a shot. So we go to the calculator one more time. And we're going to try 500 squared plus 35 squared. There it is. Take the square root of that answer. About 501 feet. Actually, that stands to reason. I mean, when you're talking about the difference between horizontal and a hill, you don't gain a whole lot. This is only a foot longer than the 500, right? So 501.2 is the value of C. All right, now I'm ready. I'm finally using my new formula, the law of sines, right? And so we're going to use the law of sines. Question, Tyler?
What is the number of
86 degrees. That was kind of the first thing I did. Was I found that using the tangent from that bottom right triangle. All right, so now I'm ready. Law of sines says if I want to know b over the sine of beta is going to be equal to, say, c over the sine of gamma. Right? And so let's fill in some things. We're going to say b is equal to, well, how about I just say the sine of beta, c times the sine of beta over the sine of gamma, right? Because I will multiply both sides by the sine of beta. I'll get b by itself. So for my example, I will do, what's my c? 501.2 times the sine, what's my beta? 2 degrees over the sine of 84 degrees. And let's see how tall the tree is. So here I go. Okay, there's my 501.2. Multiply by the sine of 2 degrees, and then divide by the sine of 84. That's a complicated problem. Now all this, what do we get? 17.65 feet. Is that correct? What did I do wrong? Oh, because, yeah, the tree is growing next to, right, the road. And so if this is a 35 right here, right? So B is, it says it's next to the road, 17.6 feet, let's say. And so they say that the answer is, where are we at? About 53 feet. Okay? So this is approximately 18 feet. Wow. And the final answer then? +18 35 equals 53 feet. That's pretty nasty. But Joe had the heads up of why the answer was what it was. All right. Good work. I could talk a little bit about the area problem. I don't think I'm going to work the whole thing out, but I will. You guys asked, so I'll say a little bit. And I did a sign. What do you guys know for a formula for area of a triangle? 1/2 base times height. That's what I remember. This other one, I don't have it memorized. I mean, to me, if I have some triangle and I want to find its area, I need to know a few things. Okay? So I know that area is 1/2 BH. And so the base, of course, could be any of the sides. You pick whatever you want. Okay? And what we've been doing is we've been calling the sides of the triangle A, B, and C, right? But the height, go ahead, Justin.
I thought the formula was the only one that was like a right triangle.
Well, the formula, you're right, it's easier with a right triangle. If I want to use this formula, I need to know this height. And the only way you can actually call it a height compared to a base is if you were to draw this extra segment here. And you have to make sure that what happens when you draw that segment. It has to make a right angle for me to really call it a height. Right angles are extremely important in application. Matter of fact, even take the tree problem we did last time. You think about how we started, we used a right triangle. And they said the tree is standing perfectly plumb, meaning it's a right angle with the horizontal. Otherwise, you're kind of out of luck. And there's a reason that people in construction care so much about being square to the, being level. Okay? So, if I knew what that height was, then I could find the area. And so, what you do is you say, well, I want to know the height, for instance, right? And this angle here, across from C, we've been calling gamma. We've been calling that gamma, right? So, one thing I could say is I could say, what can you tell me about the sine of gamma from this problem? Do you see a right triangle? Right here. See it? So what does the sine of gamma equal in that right triangle? Wouldn't it be h divided by what? It's opposite over hypotenuse, so it's h divided by a. Right? It's h divided by a. So that means that the height, h, is equal to a times the sine of alpha. Well, if I know that, not alpha, sorry, sine of what? Gamma. See that? H equals a sine of gamma. If you multiply both sides by a. Once I know that, I can put it into my friendly formula here. And I will get that area equals 1/2 b times a sine of gamma. And sure enough, that's one of the formulas in the book. Let me show you that gray box. Kaboom! They say if you have any triangle, not just a right triangle, and you don't know the height, area will be 1/2 AB sine of gamma. Okay? And then there was nothing special about the letters A, B, and C the way they were. You could do BC sine of alpha or AC sine of beta. Anyways, these are the formulas you're supposed to use for problem 21. So when they say redo, find the area of one of the other problems, all you're supposed to do is just plug in to this formula. And I guess that's all I want to really say about it for now. Okay, but I do want to do a law of the cosines problem. So again, let's go to that, and then we'll go from there. And actually, I think what I'd like to do